Hi, VencoreWeather.com meteorologist Paul Dorian here on Monday, November 24th. Well, last week we saw a lake effect snow event in the Buffalo, New York region that produced nearly 7 feet of snow over just a few day time span. Historic proportions, one of the worst lake effect snow events in the history of Buffalo. And this is primarily known around these parts as a phenomenon revolving around the Great Lakes, but really it can occur over any large body of water, and we'll talk about some of the major factors involved with lake effect snows over the next several minutes. First, wanted to start off with a little bit of a video. This is about 17 seconds long from last week from the viewpoint of Buffalo looking to the southwest over Lake Erie. A couple things I want to point out before we see this video of a snow band moving in over Buffalo. First of all, notice all the cumulus clouds. And this is indeed a phenomenon that kind of resembles summertime thunderstorm situation. That situation in the summertime can produce tremendous amounts of rainfall over a short period of time in a localized area. Very similar to what goes on with lake effect snows. Cumulus clouds build up, can dump a lot of snowfall over a short period of time over a very localized region. This particular event last week featured some 7 feet of snow just to the south of Buffalo in suburbs like Lancaster, New York, but 10 miles or so away, nearly bare ground in many areas. Again, quite an interesting phenomenon that is very localized. The second thing, just notice, you can kind of see the tremendous amounts of moisture that can come right off the lake into Buffalo with this particular time-lapse video. Let's now run through it now. And again, here are the cumulus clouds picking up moisture over Lake Erie, dumping it in the form of snow over Buffalo. And again, it can pick up a tremendous amount of moisture in a short period of time. And last week, Buffalo saw nearly 7 feet of snow. Well, here's just one of the many, many pictures that were floating around on social media last week with regard to this Buffalo lake effect snow event. Here's a car absolutely buried in snow above the car here. And again, nearly 7 feet was recorded in the southern suburbs of Buffalo. There was a point in time during this event where 4 feet of snow had fallen in places like Lancaster, New York, but just nearby at the Buffalo airport, only about 4 inches of snow. Again, a very localized phenomenon, but it can dump tremendous amounts of snow in a short period of time. Well, let's talk about some of the major factors involved with lake effect snow. And the first one here seems rather obvious, but I point that out because a large body of water is necessary. Again, we often hear about Great Lakes effect snow, but it can occur at just about anywhere where there is cold air moving over relatively warmer waters. In fact, just last week, the Chesapeake Bay produced some lake effect snow just to the south and west of the Chesapeake Bay with cold air, Arctic air flowing over the relatively warm waters in that part of the country. So this can really have an impact on any area where there's a large body of water. Again, the Great Lakes are kind of a unique feature around the world, with the largest lakes in the interior part of a continent seen anywhere around the world. So that is where we often hear about lake effect snows. Now, the second thing here listed is wind direction, and this is absolutely crucial. The exact wind direction is critical because the exact wind direction dictates how much snow will fall and exactly where that snow will fall. The longer the air flows over the water, the more moisture it can pick up and the more snow can be dumped on a particular area. We'll see in a moment here when we look at the orientation of Lake Erie how a southwest wind will be the perfect scenario for the southern suburbs of Buffalo to get absolutely pummeled by snow, just like last week where nearly 7 feet of snow fell with a persistent southwest wind flowing over Lake Erie right towards the southern suburbs of Buffalo. The temperature difference between the air and the water is critical. The relatively warm lake waters right now, this time of the year, whenever you have cold Arctic air, as we did last week, flowing on top of that, you steepen the lapse rate. You have very unstable atmospheric conditions in the lower part of the atmosphere, with the warmer influence of the water at the bottom part of the atmosphere and the very cold Arctic air above that. Again, you steepen the lapse rate to very unstable conditions, similar in some ways to summertime thunderstorms when the ground gets very warm with colder air in the upper part of the atmosphere. Finally, the last thing listed here, frictional convergence plays a vital role in lake effect snow. What happens is air flows over the water body at a relatively fast speed, and then because of the friction of the land, it tends to converge or pile up on the land, and it's forced to go upwards. Meteorologists are known to look at areas of upward motion because upward motion leads to the whole precipitation process to develop, and indeed this is what happens. Air flows over the water at a faster speed than when it encounters the friction over the land. It's forced upwards. That generates cumulus clouds and generates precipitation, and it can generate tremendous amounts of snow in a short period of time. I also pointed out here that even when the lakes freeze up, as they certainly did last year near historic proportions, something like 96-97% of the Great Lakes became ice covered by early March last winter. But even in that type of situation, you can have lake effect snow, albeit less prominent than when the water is still unfrozen in liquid form, because air can flow faster over ice than it will over the land. So you still have some kind of frictional convergence even when the lakes are frozen. Well, here's a graphical way to look at what we were just talking about. This comes from NOAA, and basically you have cold Arctic air flowing over relatively warm lake waters. In this case, for Buffalo, it was Lake Erie, relatively warm compared to the Arctic air flowing above, so the air flows at a faster value, a faster speed over the lake. Then once it encounters the friction of the land, it converges, and this convergence basically causes upward motion. All of this results in the formation of cumulus clouds and ultimately snow. And again, it can produce tremendous amounts of snow over a short period of time in a localized area. So the frictional convergence here, the friction of the land, causes the air to slow down, and that tends to pile up and cause upward motion, which in turn results in heavy amounts of snow. Well, the last map I want to look at this morning is just a map of the Great Lakes, because I want to focus in on wind direction, because again, that is a critical factor with respect to lake effect snow. Now, Buffalo, New York happens to be located right about in this region right here. Now, the perfect scenario for the southern suburbs of Buffalo to get pummeled by snow, as was the case last week, is with a southwesterly flow of air going all the way across Lake Erie. You can see it heads right towards the southern side of Buffalo. This kind of a trajectory does a couple of things. First of all, it allows the air to flow for a longer period of time over the lake. In fact, the longest possible period of time, given the fact that the lake is oriented from the southwest to the northeast. This kind of a flow produces tremendous amounts of snowfall. Now, the second thing, just notice right on the other side is the southern suburbs of Buffalo, and that is where this kind of a snow event can dump 7 feet of snow in just a 2 or 3 day period, as was the case last week. Now, notice here that if the flow was flowing out of the northwest, for example, in fact, let's clear this right here and show a northwesterly flow in this direction. Well, it just so happens that Buffalo would be in the clear, but Erie, Pennsylvania, is right in this region right here. So the flow flowing in this direction would produce significant snow in the lake, in the Erie, Pennsylvania region. But since it flows over a shorter span over the lake, You don't often hear about Erie, Pennsylvania getting walloped like Buffalo, New York can, just because of the orientation of the lake from the southwest to the northeast. By the way, a southwesterly flow over Lake Ontario, very similar to Buffalo getting pummeled, can hit hard the Watertown, New York area, which is right in this region right here. Now notice also Lake Michigan. Now that particular lake is oriented from the north to the south, so a northerly flow of air here, which can certainly happen if there's a strong low pressure in this region right in here, for example. You could have northerly flow of air over Lake Michigan, and because it's oriented north to south, the air will flow over the relatively warm lake for a long period of time. That allows it to pick up a lot of moisture, and in this kind of a scenario, Chicago or nearby areas near Chicago can get absolutely pummeled by snow as well. So a very interesting phenomenon called the lake effect. Primarily hear about it in this part of the country with regard to the Great Lakes, but it can occur over any large body of water. That's it for now for a detailed explanation of lake effect snow. I'm glad you visited VencoreWeather.com. I'm meteorologist